Today we're going to talk about three basic exponent rules. We started to hint at these in your homework yesterday. You had homework yesterday where you had to expand some exponents, and then over here we were kind of hoping that you would look at and see what was going on with these exponents after you expanded them. So like 5 to the 5th power and 5 to the 4th power becomes 5 to the 9th power. We're adding those together. Okay, today we're going to talk about these with a little bit more structure and make sure we really understand what's going on. Okay, so basic exponent rules is our topic. What we need to know is simplifying exponents. When are we done? They are completely simplified when there are no zero exponents, and I'm actually going to add to this. There are no zero or negative. So go ahead and add that in your notes packet. Okay, there are no zero or negative exponents. So in the end of our problem, we will have no zeros and no negative exponents. There are no parentheses left in the problem, and there's only one of each base. So for instance, I'm not going to have x to the 2nd power and x to the 5th power in the answer of a problem. There would only be one x, one y, that kind of thing, in the end of my problems. Okay, the first rule that we're going to talk about is exponent multiplication properties. When we are multiplying two powers with the same base, we keep the base and we add the exponents. So we see here I'm multiplying together, okay? I'm multiplying x to the 7th and x to the 4th. They have the same base, okay? We're going to keep that base exactly the same. So in my answer, x is still the base of my answer, and I'm going to add those exponents, 7 plus 4, okay, which is the same as x to the 11th power. Okay, so when I simplify two of the same base, I add the exponents to simplify. Now, it's a little bit different when it looks like this. When there is a power outside of parentheses, like we see here, a 2, this 2 exponent outside of parentheses, we give it to every base, and we multiply exponents when we do that. All right, one of the most common mistakes here is to not give this 2 power to the 4 base at the very beginning. Okay, this 4 actually has a 1 exponent attached to it, even though we can't see it right there. All right, so when we do this, I'm going to multiply my exponents. So I'm going to give this 2 to the 4, and 1 times 2 is 4 to the 2nd power. Okay, I'm going to multiply these exponents, the 3 and the 2, so this becomes x to the 6th power. And then finally, I'm going to multiply here y to the 5th power, and I'm going to multiply that exponent by 2, so y to the 10th power. All right, we can simplify that a little bit further by going ahead and finding out what 4 squared is. 4 squared is 16, x to the 6th power, y to the 10th power. Okay, so these are our multiplication properties. Two of the same base, I add the exponents. Exponent outside parentheses, I give it to each base, and I multiply my exponents. We can kind of think about it a little bit like distribution. All right, let's try some examples of this work. Okay, here I see I have two of the same base, x and x. I'm going to keep that base, and I'm going to add my exponent. 6 plus 3 is x to the 9th power. All right, the next problem gets a little bit more complex. I do see that I have two bases of x in my problem. So I know, I'm going to leave a little bit of space here because we still need to deal with these coefficients, these big numbers out in front. But I know that I'm going to add the exponents of these x's. So this becomes x to the negative 4 plus 2, which is the negative 2 power. Okay, and what I do here with my coefficients, I'm basically just multiplying everything here. So I'm going to multiply. The big numbers all get multiplied together here. So 3 times 2, which is 6. And I'm going to put that as a coefficient in front of my x. All right, so now we've done some work there, but I always want to double check. Am I completely finished simplifying this problem? I'm going to go back to the first thing we saw here. There are no zero or negative exponents left in my answers. So when I look at my answer here on letter B, I know that I'm not quite finished. I still see a negative exponent. Now, we talked about this last time in class. If I have a negative exponent, it's unhappy where it is. Okay? This x is up on the top of my problem. It's unhappy there and wants to move down to the bottom. When it moves to the bottom of the problem, the exponent becomes positive. So instead of x to the negative 2 power, it's now x squared. The 6 was perfectly fine where it is, and it remains up on the top of the problem. So completely simplified is 6 over x squared. All right, we don't want to leave any negative exponents in our answers. All right, let's try one last problem. Here I see I have x's and y's in the problem. All right, so it makes it a little bit trickier. Again, we've got coefficients. The 4 and the 5 here that are the coefficients of my terms are going to get multiplied together. 4 times 5, or 5 times 4, sorry, is 20. Then I'm going to deal with my x's. I see x to the 3rd power, and x squared. I'm going to add those exponents. Okay, 2 of the same base. I'm going to add the exponent. This is x to the 5th power. All right, and now I also see that I have my y's here. Okay, what I don't see on this second y is an exponent. I know that when I don't see an exponent, though, that there's a 1 there. So if I add these together, this is y to the 6th and y to the 1 power. I add those exponents to be y to the 7th power. I see that I have no negative exponents, I have no 0 exponents, and I only have 1 of each base, 1x and 1y. Okay, so I know that I'm finished with that problem. All right, let's try a few examples of the other property we looked at. All right, here I have an exponent outside parentheses that I need to give to each base, and when I do that, I'm going to multiply. All right, so here I go, x to the 2nd, and then I'm going to give this 4th power to that by multiplying. So this becomes x to the 8th power. All right, and again, I have to do the same thing here for the y. This becomes y to the negative 3 times 4, which is negative 12. Okay, we have to remember again that we don't want to leave any negative exponents in our answer. All right, what we're going to do is turn this into a fraction problem. The x to the 8th power is just fine where it is, so it's going to stay where it is on the top of the problem. The y to the negative 12, it's unhappy here on the top. It's going to move to the bottom, and the exponent becomes positive. So this is x to the 8th over y to the 12th. Okay, we know we're completely done. There are no 0 exponents, and there are no negative exponents. All right, example E. Again, we're going to give this exponent outside the parentheses to each base. We're not going to forget to give that that 3rd power to the 6 here. So this becomes 6 to the 3rd power, and we're going to multiply to get our exponent for the a to the 9th power. Okay, we can simplify once again by finding out what 6 to the 3rd power is. I'm going to have to do that in my head here real quick. I know 6 squared is 36 times another 6 is going to be 216. You could just type that in a calculator. 216 a to the 9th power. I have no 0 exponents, I have no negative exponents, and I have just 1 of each base. So I know I'm finished with this problem. All right, one last problem. Okay, negative 4, x to the 3rd, y to the 9th, all squared. I'm going to give this 2 power to each base, okay, multiplying exponents as I go. The tricky part here is that this is a negative 4, okay, to the 2nd power. So when I think about that, I think about it as the negative 4 in parentheses. Negative 4 to the 2nd power, x to the 6th power as I multiply those exponents, y to the 18th power. When I simplify negative 4 squared, negative 4 times negative 4 becomes positive 16. That's why we have to be careful there. Typing this in a calculator, we would definitely want to put those parentheses. Okay, or I want to think about it as negative 4 times negative 4, which is positive 16. Okay, my x to the 6th, y to the 18th. Okay, so these are our basic multiplication rules for exponents.